And recalling that we defined a radian to be the arc length over the radius. So if we're to look at 1 radian, then that means that should equal that S over R should equal 1. So we would have the arc length S should equal R. What that means is if we have a circle with radius R, 1 radian is about something like this, about 1, and we take our radius, we don't erase it, we take our radius and we move it and we kind of lay it over this circle, and that should be about the same unit. Then if we had 2 radians, that has a length of R. We have 2 radians, then we lay it over again with another length of R. Keep going on. 3 radians is just about over here. 4 radians puts us around over here, so we get another R. 5 radians puts us into quadrant 4. 6 radians, another R, another radians, and then we have just this tiny little bit that we didn't quite get. So if we were to go around this full circle, we go all the way around this circle, what we would get approximately 6.28 radians, which actually ends up being 2 pi. A full circle is 2 pi radians. So to convert from degrees to radians, multiply by 2 pi over 360, or pi over 180. So I always think about a full circle has 2 pi degrees, or 2 pi radians, or 365 degrees. And then likewise, to convert from radians to degrees, we multiply by the inverse. 360 over 2 pi, so 360 degrees over 2 pi radians, or 180 over pi. So we're just looking at how many degrees are in a circle versus how many radians, and we can make that conversion. If we have 45 degrees, then to convert it to radians, we would multiply 45, we can keep degrees, times our conversion, 2 pi radians, that's in radians, over 360 degrees, our degrees would cancel, and we get 45 times 2 times pi over 360. This simplifies. 45 times 2 is 90. 90 over 360 is 1/4. So we get pi over 4 radians. And then if we wanted to, let's say, take 5 pi over 6 radians to degrees, we would then multiply 5 pi over 6 times 360 degrees over 2 pi. Our pi's cancel. And then when we're writing radians, you don't need to write the units. So our degrees cancel, or our pi's cancel. And now we have 5 times 360 over 6. And that simplifies to 150 degrees. Right, so we now have a way to convert back and forth. And here are some useful angles that we'll be using throughout this course for both radians and degrees. So we have 0 radians is 0 degrees. Pi over 6 radians is going to be 30 degrees. pi over 4 radians gives us 45 degrees. Pi over 3 radians, 60 degrees. Pi over 2 is 90. 2 pi over 3 is 120 degrees. 3 pi over 4 is 135. 5 pi over 6 is 150 degrees. And then pi is 180 degrees. And then continuing on, then we would have that pi, as we said, was 180 degrees. 7 pi over 6 is 210 degrees. 5 pi over 4 is 225 degrees. 4 pi over 3 is 240 degrees. 3 pi over 2 is 270 degrees. 5 pi over 3 is 300 degrees. 7 pi over 4 is 315 degrees. 11 pi over 6 is 330 degrees. And then 2 pi is a full circle, or 360 degrees. Now, in a circle with radius r, and then arc length of s, and with a central angle of theta, then we have the relation that our arc length s is equal to radius times theta. This is where theta is in radians. Okay. So that is, we have a circle, and we have an r, and we have some sort of angle. Let's say the angle is out here, and that's theta. Then this arc length right here, s, is r times theta. So, for example, if we have an arc length or we want to find the arc length, and we're given a circle with radius is 10 centimeters, and we have an angle of 120 degrees, we can find the arc length. S is r times theta. So r is 10 centimeters, theta is 120 degrees. But we need to convert this to radians. So pi over 180 degrees. 120 over 180, we can divide by 10. And then 12 over 18, 6 goes into 12 twice. So 6 goes into 12 twice, 6 goes into 18 3 times. So we have this, and then multiplying by 10, we end up with 20 pi over 3 centimeters, and that's the arc length. We also have a formula for finding the area of a sector. So if we have like a circle, and we have just some angle theta right here, and a radius r, the area of the sector is theta over 360 degrees times pi times r squared. This is if theta is in degrees, or the area is 1/2 r squared times theta if theta is in radians. Essentially what this is saying is that this area of this sector, the proportion of this area over the full circle, it's the same proportion as theta is to a full angle, the angle of the full circle, 360. And so if we had an example where we had our angle is 67 degrees and we had a radius r is 50 meters, then the area that's enclosed by this is going to be, we're dealing with degrees, so this is 67 over 360 degrees times pi times 50 squared. And this is approximately 1,462, if we're rounding up, meters squared. That is the area of the sector.